So just to review sum and difference formulas really quickly, let's do the sine of 255. 255 is not on the unit circle, so I need to create 255 from angles that are on the unit circle. So we could say the sine of 210 plus 45. And then you look at the sum and difference equation. Are we doing the sum version or the difference version? The sum version, because we chose plus. So it would be the sine of 210 cosine of 45. What sign goes in the middle? Plus the cosine of 210 sine of 45. And then we just pull those numbers off the unit circle. The sine of 210 is negative 1/2. The cosine of 45 is root 2 over 2, plus the cosine of 210 is negative root 3 over 2, and the sine of 45 is root 2 over 2. And I end up with two fractions that are both over 4. So we get negative root 2 minus root 6 over 4. And every time you do one of the sines or cosines, you're going to end up with something like this. Okay. What if I did the cosine of 15 degrees? How would you create? Well, and if it says pi over 12, I would just convert it straight into degrees, because adding fractions in your head is kind of hard to do. So the cosine of 15, how do you create 15 degrees? 40, yeah, it's the difference between any two adjacent points in a quadrant. So we could say the cosine of 60 minus 45, or 30, or 45 minus 30, or 150 minus 135. There are a whole bunch of ways to do that. But this is the difference formula for cosine. What do you do in the difference formula for cosine? You add. If you look at the formula sheet, it says the cosine of alpha plus or minus beta, and then inside the formula it says minus or plus. So the sum formula you subtract, and the difference formula you add. And the arrangement of the sine and cosine is a little different too. It's the cosine of 60, cosine of 45, and then plus sine 60, sine 45. Cosine of 60 is 1/2. Cosine of 45 is root 2 over 2, plus sine of 60 is root 3 over 2. Sine of 45 is root 2 over 2. And we end up with root 2 plus root 6 over 4. Is everybody okay with those? All right, now let's go back up here. What if I wanted the cosecant of 225? There is no cosecant, or 255, sorry. There is no cosecant formula on your reference sheet. So what do? You flip the sign upside down. So we ended up with negative root 2 minus root 6 over 4. I'm going to flip that, and I'm going to get 4 over negative root 2 minus root 6. Two things I don't like about that. It begins with a negative, and it has square roots on the bottom. How can I fix the negative problem? Change every sign. So I'll make this negative, and then I'll make those negative, or positive. Negate what's there, sorry. Now what? I have to multiply the bottom by its conjugate. So I'm going to multiply it by root 2 minus root 6. And then I have to times the top by root 2 minus root 6. The top ends up being negative 4 root 2 plus 4 root 6. Right? And then the bottom, that gives me 2. What about this one? It's going to cancel because we have conjugates. So that one cancels that one. And then this one turns into -6. And I end up with -4 root 2 plus 4 root 6 over 4, -4. I divide everything by -4, and these cancel, and this cancels, but it turns into a negative. So the answer is root 2 minus root 6. Okay, going down here, this is the cosine of 15 degrees. What would the secant of 15 degrees be? Well, we flip that upside down. 4 over root 2 plus root 6. Do I have any problems with the signs? Nope, I like how the signs are set up. So I'm just going to flip it. Or I did flip it. I need to multiply by the conjugate. Root 2 plus, or root 2 minus root 6. And why am I allowed to do this? It doesn't change the problem because I'm multiplying by 1. So I can multiply by 1 without altering anything. We're just putting some makeup on this so it looks better. So on top, 4 root 2 minus 4 root 6. And then on bottom, I get 2. And then this one and this one are going to cancel. And that one gives me -6. So 4 root 2 minus 4 root 6 over -4. I can divide that out and I get negative root 2. And I can divide that out and I get positive root 6. And you could switch them so that it says root 6 minus root 2. Okay. So, any questions about sines, cosines, secants, or cosecants? Is there a tangent problem you want me to do? Or a cotangent? How about we do 11? So, it would be the cotangent of 15 degrees. Pi over 12, right? Pi over 12 is 15 degrees. All right. We could use the tangent formula and then flip it upside down, but I think that's a waste of time. What I would suggest is you do the cosine of 15 and divide it by the sine of 15. How do you create 15 degrees? 45 minus 30. So the cosine, so I want to do the cosine of 45 minus 30 over the sine of 45 minus 30. So that will be cosine 45 cosine 30. What sign do I use? Plus sine 45 sine 30. And when possible, it's really nice to use first quadrant angles. Why do we like first quadrant angles? The answers are always positive. It's also nice to use third quadrant angles because they're always negative. So you don't have to think very much about what the signs are. Okay, this will be root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1/2. So that gives me root 6 plus root 2 over 4. Now we're going to do the sine. Am I going too fast? So sine of, I'll write it out. So sine 45 cosine 30 And then what sign do I use here? Minus. Good. Cosine 45, sine 30. That will be root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1/2. So that gives me root 6 minus root 2 over 4. Okay, halfway there. Just want to set them back there somewhere. Now I need to do the cosine divided by the sine, and the easiest way to do that is just flip the sign upside down and multiply. So I have, what was it? Root 6 plus root 2 over 4 times 4 over root 6 minus root 2. 4's cancel. Root 6 plus root 2 over root 6 minus root 2. I need to get rid of the radicals. Do I want to change any of the signs? No, it looks pretty good. 3 positives, 1 negative. That's a good setup. So I'm not going to change the signs. But I need to multiply the bottom by the conjugate. Root 6 plus root 2. And then multiply the top by the same value. Root 6. Whoa, that's a 6. So on top, we get 6 plus 2 copies of root 12. Does everybody understand that? So 2 copies of root 12. Why didn't those terms cancel? They're not conjugates. They're identical. So conjugates, the middle term cancels. Identical factors, you end up with 2 copies of the middle term. And then the last one is plus 2. And then on bottom, I get 6. And then root 12 is going to cancel negative root 12. And then I'm just left with plus 2. Minus 2, thank you. Now, 2 root 12. That simplifies. So 12 is 2 times 2 times 3. Can I pull anything out? A set of 2's. When I bring that 2 out, there's already a 2 there. You multiply. So root 12 is really just 2 root 3, but there's already a 2 here, so it ends up being 4 root 3. And what am I really doing to root 12? Why does it simplify? I'm pulling out the perfect square. So if I had the square root of 75, are there any perfect squares in 75? 25. 25 times what? 3. So the square root of 75 is really 5 root 3. What about 72? Are there any perfect squares in 72? 4 and 9 and 36. So 72 is 36 times 2. What's the square root of 72? 6 root 2. Okay, what if I had 54? Are there any perfect squares in 54? 9. 9 times 6. So we square root the 9. 3 root 6. Okay. So that gives me 8 plus 4 root 3 over 4, which turns into 2 plus root 3 if I divide out the 4's. All right. Okay. So look at number 18. Number 18 says, simplify into a single trig function. So I have the sine of x times the sine of 2x minus the cosine of x times the cosine of 2x. Does that look like any of my sum or difference formulas? It kind of does. It kind of looks like the cosine. What's wrong with it? It's backwards, so let's change it. So negative cosine of x 2x, or cosine of 2x, plus the sine of x sine of 2x, or pull out a negative, right? We can't lead with a negative. So I'm going to take a negative out of both of those. And I get negative 1 times, it's right here. So the cosine of x, cosine of 2x, and then what will be in the middle? Minus the sine of x, sine of 2x. So what is this? That is the cosine of x plus 2x, right? So the negative cosine of x plus 2x, does that simplify? It's 3x. So the negative cosine of 3x. So the negative cosine of 3x is equal to that problem in number 18. Okay, and that's all you're doing in these problems. Nope. Sorry, got a little warm. Okay, number 20. Does number 20 match up with anything we see? Yeah, it's a straight up sine. Oh, wait a minute. Wait a minute. Did we mess up? No, we didn't. We're good. Okay. So number 20 is going to be the sine of 2x plus 3x, which is just the sine of 5x. That's it. That's the formula. We're going backwards. Look at your reference sheet. Right? This is alpha, beta, alpha, beta. So we're going backwards. Look at your sum and difference formulas. The sine. So we're using the right side to create the left side. Okay. Look at number 22. Does 22 match up with anything we have? Yes, it matches up with the sine difference formula. Right? It's the bottom half of the sine formula. So we're going to say the sine of pi over 3x minus, this is a sine, so, oh, I see. So negative pi over 2x. Okay. What is pi over 3 times pi over 2? Nope. What is pi over 3 plus pi over 2? We have to turn them both into sixths. So 1/3 plus 1/2 be 3 over 6 plus, dang it. It's 3 over 6 plus, or sorry, 2 over 6 plus 3 over 6 is 5/6. So it ends up being 5 pi over 6x. Okay. Okay, hang on a second. My board died. Because he's in kindergarten? Okay. Hey, what's up? Oh, great. Okay, 24. 24 we're going to need to simplify. Yep, they're squared. So what is sine A plus sine B squared? It's going to be, so sine squared of A plus 2 copies of, so I'm doing sine A plus sine B times sine A plus sine B. So sine A sine B plus the sine of B, sine squared of B. We put the squareds in front of the letters because it eliminates problems. What's up? Sure. She's not here today. Okay. What about the other one? What is the cosine going to look like? It's the same, basically. Cosine squared A plus 2 cosine A cosine B plus cosine squared B minus 2. That is a big mess. We can simplify. No. Look at that negative 2. Why is the negative 2 there? Is cosine squared minus 1 on your reference sheet? It's 1 minus cosine squared. So what we need to do is switch these to cosines, and then the 1's will cancel. Right? So this is 1 minus cosine squared of A, right? Well, and this one is 1 minus cosine squared of B. And what do you notice? I have a negative cosine squared A and a positive cosine squared A. And I have the B's. And then I have a 1 and a 1, which cancels the negative 2. Now I'm left with 2 sine A sine B. What? They're not divided. They're just converted. This is not a division line. It was an underline. I just took sine squared and turned it into 1 minus cosine squared. So 2 sine A sine B plus 2 cosine A cosine B. That almost looks like the cosine formula. There's no square. The squares are gone. So I need to do 2 things before it matches up. The 2 is a problem and the order is a problem. I actually want to factor the 2, pull the 2 out. And I also want to change the order. I'm going to put cosine first. So cosine A cosine B plus sine A sine B. Now, this matches up with the cosine, the difference formula. Does everybody understand why it's the difference formula? Okay. So we end up with 2 times the cosine of A minus B. Actually, I don't even need those parentheses. 2 cosine A minus B. All right. Do you want to see 26? So 26 is the same, but are you guys, you're okay with 26? Because you're going to do, uh, they're not conjugates. Wow, 28. Okay, but you think you can, 26 is really similar to 24. You're going to do one like 24 and one like 26. But I think you can figure that out. But 28, we need to do that one. Well, 28 is actually pretty easy. If you look at your formula, what is it going to be? It's just the tangent of 49 plus 23. So the tangent of 49 plus 23, which is really just the tangent of 72. And you're done. Yeah. It will. No, it should be plus. Well, if I had this, I would convert it straight to that. That's what the tangent formula says. Now, we don't use the tangent formula because sine over cosine is easier. But in this case, when you go backwards, you definitely want to use the tangent formula because there are only two steps. Go backwards and then simplify. Okay. Get to work.